This is Group 5, comprising of me, Aurodeep, and my partners Ashish and Thirumalai, who would be presenting the partial indexing, median, and mode extension development for the H2 database. Let us first see what the H2 database is. So H2 database is an open source engine which is managed by the team called h2.org. It's a fast database engine. It is written in Java and actually supports SQL and the JDBC API. It's a minimal sized database of size probably ranging to some MBs, and it does have clustering support and embedded and server modes as well. It can actually work as a distributed data source in terms of widespread deployment, and in certain cases PostgreSQL ODBC driver can be used for accessing it. It also does support multi-version concurrency. There are certain indexes that are used by H2 because we are primarily looking at partial index development. Let us see what are the different kind of indexes that are in use as of now. They are hash index, function index, linked index, page data index, spatial index, and view index. Our major source of concern is the page data index, which are of a variety of types. We would be actually dealing with the development of the partial index based on page B tree index and page delegate index, which are part of the page data index segment. Let us also look at a few of the limitations of the H2 database. It does run into certain problems with larger sized data sets and databases, but works perfectly fine with medium sized data sets. It also does possess some durability problems in terms of persistence, and it does also have persistence problems in terms of power shutdown, so resulting in imminent data loss. Now let us look into certain implementations about what extension developments we have done for the H2 database. We'll be first looking at partial indexing, which is basically index built over a subset of the table, or we can say that the index which is built on certain conditions. The syntax that is actually followed in this case is actually like create index on table name when a certain condition is satisfied. Partial index implementations have been done in a few of the databases already, ranging from PostgreSQL to SQL Server, and this partial index development is actually in the future roadmap for the H2 database as well. So we are currently experimenting on this. Let's hand it over to Thiru, who would be doing a code visualization as well as the changes in the GUI implementation that have been affected due to partial index implementation.
Basically, partial indexing involves building index on a subset of table based on certain conditions. When it comes to any query involved H2, the first page it comes to is parser.java, where it checks the constraints of the query, whether the query is fine, and certain the main job of the parser is to parse the query to check whether it is written correctly and then start executing it. So to involve partial indexing, we just need to allow the parser to accept the conditions for partial indexing. So for creating index, when it comes to the parser.java, it just primarily parses the entire query, and it does not accept var class. So I had written a particular statement where it accepts the var class and then gets the condition from the var class, store it in an expression condition, and then return the command so that it could be executed. Let's see how it works. When the database is connected, here there are already 3 tables there, which are marks, scores, and test, which can involve partial indexing. So I'm gonna create typed index. Now I'm greater than some 50. So now if we run the query, here the index 1 already exists, that's why it gives the error. Yeah, it runs successfully because it accepts the var condition, and during the execution phase I had include uh, included a condition object in the index variable, which is stored along with its properties inside the information schema. Let me show you that. Yeah, here is the condition. This condition stores the condition for partial indexing if it is there, and then during execution and creation of new rows, this condition is cross checked when an index is created. If the condition is met, the index is created for the particular row. This is how we implemented partial indexing. And the partial indexing is basically built upon page tree index and page data index just for now, and it works fine. Next, let's see about the mean and the median and the mode part of the code. Ashish will be explaining the mean and median and mode part of the changes which we implemented.
Hello. So first we are planning to do the adaptive index buffering, as you know already, but later on we change it to median mode. This is the case because this adaptive index buffering we were not able to visually implement it in our GUI, and median mode we can show it easily into GUI. So here our plan is to implement some keywords, implement keywords and give them some names like new aggregate functions, and test them using multiple tables. Tables can be of any type like integer, float, or decimal. As we know that most existing database like Oracle and SQL, they already have some sort of aggregate functions like average, sum, count, etc. For H2 we decided to implement median mode because it doesn't have these functionalities. For that we have to change some code into its database. We took some extra measures not to break the functionalities of other non-numeric data types for these things. We made sure that the new aggregate function doesn't work for non-numeric data types like varchar also. So for this we made changes to the aggregate.java. Here we have chosen, like for median mode we have given a static function, static method call. So here we have changed the code, a case. Yeah, so for this you can see here that we have here we will be showcasing the code changes.
Hi, just with partial indexing, the aggregate functions which we are about to implement also needed some change, a little bit of changes in parser, but it doesn't involve much, as there are many other aggregate functions like count, sum, min, max, etc. We have to implement was we had to define a type for the median and mode, which is defined over here, and make sure this type is selected during the execution part. And to make sure that the non-integer data types are not handled, we included a code part where it just leaves out the varchars and characters, and it takes up only the numeric data given if it is integer, double, or float. This is done over here. Like if it is in the case of median and mode, it checks for the data type, and H2 stores its own data type in a of the form called value, and this value is a superclass for all the other data types like string, integer, varchar, char, blob, glob, etc. So it checks for that particular data type, that is integer, and throws the error if it is not of an integer data type or float or double. And Then we also changed one other file called aggregate data default, which is called during execution part, and this is where the actual code for the median and mode are implemented. Like it checks for the type for median and mode. If it is either 15 or 16, it comes to this part of the code where it, for median, it temporarily stores all the data in the table to a array called value array, and this value array is sorted below, and once all the rows are red and the column value is stored for the median, it just checks for the middle value if it is if there are odd number of integers, or it averages both the middle values and displays the results. In case of mode, it checks for just a minute. In case of mode, it checks for the repeated values which is stored in the hash map, so it increases the count of each value present, and then gives out the result of the maximum value, or it just displays null if there is no repeated elements found. Let Ashish show this in the GUI part.
Thanks, Thiru. So for the median, we have inputted some value in our tables. Like we have these values, around 19 values, and we will implement the median and mode function over this. So we will type the command for the implementing the our numeric value in the scores table in its score. So this is a total command. We can run both the median and mode at the same time. After running a command, as you can see, it shows the median and mode. We have rechecked the values and it is showing it correctly. Also, so this is our error. This will here you can see that it is showing that sum or average or median or mode or wrong data type. This is because in name we don't have any value which are stored. Name is a varchar, that's why it's showing. And now moving to the as you can see, the name is varchar. Now moving to the conclusion part.
Hi, I will be picking up from where Ashish left, and I will be concluding on our project demo. Our main conclusion is why we implemented these extensions. Partial indexing actually helps when we are actually retrieving data from a very big data with a minimum amount of conditions. Like if we are only retrieving a subset of the actual data every time, so partial indexing actually helps. In that case, indexing the whole table, or in fact even a whole column, does not help. And if we have certain conditions on we are indexing and we are selecting only those conditions, so we have faster data retrieval. Other than that, why we went for median and mode implementations is because most of the databases do not have custom implementations of these kind of functions, and the closest match is the mean or the average. But in order to do certain kind of mathematical calculations which can like use median or mode, either we have to write some custom functions or stored procedures, or do it in the front end by handling the data after retrieval from the database. So instead of that, we provide the end user the utility of using these functions, these custom inbuilt functions, using which he can do some mathematical calculations, which basically are termed as median and mode. These can be extended to statistical calculations as well, which use median and mode functions. What actually we learned from this extension implementation is how to look into the actual code implementation of the database and seeing what a database internally looks like. We before the course and the project, we initially had handled databases only in an agnostic way, and we were looking at SQL implementations where we would query the database and retrieve the data or make changes into the data stored into the database. But how the actual indexes are being created and how the data is actually stored, what kind of data types are actually handled within the database, and the baseline implementation of the database. That is what we learned doing this project. It was a very informative session for us, and we would be looking forward for implementing many more extensions for the database. Probably use those extensions in custom SQL implementations or even in front-end applications. So signing off on the project presentations, me, Thiru and Ashish would like to thank you all.